So,
Can you not?
Holy smokes.
what?
Nothing.
So,
Yeah.
we want to do 11.7 number 10, which says costs will double in 9 years due to inflation. What's the rate of inflation? And Ethan was jumping the gun here and explaining why we don't need the initial.
Because you can write the initial in terms of the output, so it would just be like, I used A in the book because A makes more sense to me than
Okay.
the formula that we used to have, that you gave us the other day.
So the formula I gave you the other day was something like this, right?
Yeah.
Except with the P.
Except with
Yeah.
P's,
Yeah.
right? Why did I change it to A's? And does it matter?
Doesn't
It
matter at
doesn't,
all.
but the P is population, so.
P seems like it stands for population. A stands for
I remember.
amount. Right? So traditionally, when you're not doing inflation or when you're not doing populations, you write A instead of P.
Okay,
Awesome.
so it's going.
And now
up,
you
so
were
it's
saying-
positive.
Okay, so the initial would be A and the end would be 2A because it doubles.
Okay, so you're saying, all right, on the one hand, we've got, it goes to twice whatever the initial was, right?
Yep.
And on the other hand, it should be given by the formula.
So
Yeah.
it should be, that O should be a T then, right?
No.
The time's still.
I'm looking for the, am I
In
looking
9
for the
years.
time?
No, it gives you the
Right.
rate, it gives you the time, right?
Yeah, I'm looking for the rate. They gave me a time. Where should the 9 go?
9
Where
for
T
T there and T.
Yeah, that should go in for T. This kind of makes sense. On the one hand, right, my model says that in 9 years, this will be the
Right.
answer. And on the other hand, right, in the problem, they say that it'll double. And this is really how I'd kind of like you guys to think about these. When you're doing solve problems, right, not the evaluate problems, but the solve problems, there's like a, on the one hand, there's a model. And on the other hand, there's whatever they told you.
Okay. And this is for the solve ones?
Yeah, this is for the solve one. The evaluate ones, of course, you just cram everything in, turn the crank on your calculator, right, and get an answer. You guys see that? I know this is a solve one too because they're asking me for,
A variable.
Rate.
yeah, they're asking me for a rate or a time. They're not asking me for a,
And how long?
yeah, what's the amount, right? They're not asking me for the output, they're asking me for one of the inputs. You guys see that? All right, so here I got this. What do I do with this?
Divide by A.
Oh, okay, yeah. Of course we could divide both sides by A naught, right? So I'll figure out that 2 is e to the, that's awkward, right? R times 9? What would you write instead? 9R. Okay, then what?
Then you do.
Log that shit.
Natural log both sides? Okay, so what do you get on the left?
Natural log 2.
Okay, so we got the natural log of 2
9R.
is 9R,
Yeah.
and then what?
Divide 9.
Divide by 9. So you get R is natural log of 2 over 9. Oh, I kind of gave away the answer to my next question. What was my next question going to be?
Oh, I didn't even write it.
Yeah, what's the 9 under?
Oh,
You guys see that?
yeah.
What do I mean to do with this thing?
You need to natural log 2 and then divide the answer by
And
9.
then.
Yeah, I mean to feed 2 to the natural log, right? And then divide by 9. You guys want to try that? Give me a number.
7.7%.
What? Oh, no, I heard you wrong. 7?
So yeah,
Yeah.
essentially.
That's, okay.
Yeah.
Okay, so I got 0.077 out of my calculator.
Yes.
And when I want to phrase this as a sentence, right? What's the rate of growth?
The rate of growth.
7.7%.
Yeah. So this is R, right? I suppose this is approximately R, maybe. Again, I don't really care about your guys' approximately equal to on here. These are really models, so these are all approximations. Everything from when I started writing down this thing, everything here was an approximation, so I'm not going to hang up on your equal signs being hard or soft on these, okay?
Okay.
So we write something like the rate of inflation is 7.7%. When does 7.7% happen? What's the?
After 9 years.
Cool.
Not after 9
New
years.
ones?
It doubled after 9
Doubles,
years.
yeah.
When's 7.7?
At initial.
Continuously.
Every year?
Yeah, it's continuously, and your book uses that as a byword for per year. This R and this statement are a little bit at odds with one another, but they're close. And it's all a model, so we'll go with it for now. Cool. If you go on to, like, get a master's degree in applied math or something, this will not, in fact, be a reasonable interpretation of what R means. But right here, right now, this is fine. Other things? Anything on this? Did it matter what an item cost? Like, did it matter what costs were when I started?
No.
Why not? Where'd they go?
We did like it anyway.
In the A, right?
Yeah, we divided here by A naught, right?
The A now.
You guys see that?
Yeah.
A naught.
Okay.
Does that make sense? Like, if the cost of bread doubles due to inflation, right?
Yeah.
Probably the cost of
Everything else will go.
Mhm.
everything else will double too, because it's just inflation, right? It's not because bread got more scarce or something, right? Cool.
9
It's
years.
similar to population too.
Yeah, and it is exactly similar to population.
It's like started here, anything starts here, goes here, then give you this in, it's like,
Yeah. Yeah, really, we could think about this as kind of the population of money available. That's really actually sort of how this is working.
yeah.
Yeah, and this was actually an interesting observation. If costs double in 9 years, it's a little bit extreme, right? Inflation of 7.7% is actually really, really high. You guys know what inflation runs?
Zimbabwe.
It's not quite Zimbabwe. Zimbabwe's inflation was up to like 10,000%. You guys know what inflation runs in the U.S.? Kind of.
It's fairly low.
Point something.
Yeah, I think it's 1 point something percent. Yeah, it's relatively low. It's nowhere near 7.7. 7.7 would be a lot. Cool. Questions, things?